Okay, so let's take on two problems, problems 44 and problems 45 on page 4 Fahrenheit 451. You have a sister problem. It's number 51 on that same page. And as if doing two problems weren't enough, let me actually start with problem 39 on this page. Problem 39 says find the exact value of this composite function, arc cosine of the cosine of 4 pi all over 5. I will warn you, I get a little daffy on these problems, so watch me. When we studied inverses, remember we studied inverses sort of as a prelude to learning about exponential functions and logarithmic functions, given that those two functions are inverses of one another. And one of the things I tried to stress with you is that a function and its inverse sort of undo what the one or the other does. And the way that transforms mathematically is to say that f to the minus 1 of f of x is equal to x. And I hope that I've trained you so that if you see cosine 45 and then take the inverse of the cosine, you should just run over here as quickly as you can and write down 4 pi over 5. Congratulations to you if you did that or you've done that. But now let me disabuse you that that's not exactly the right thing to do here. And the difference is the following. When we studied inverses beforehand, the function that we found in inverse was everywhere 1 to 1. Everywhere 1 to 1. And its inverse, likewise, was everywhere 1 to 1. And you might remember that when we started to define inverses of trigonometric functions, we probably started with sine, but here's cosine. And we said, yikes, cosine does not in any way, shape, or form pass the horizontal line test. It's not 1 to 1. So what you have to do with all of the trigonometric functions, because they're all periodic and they all fail the horizontal line test, what you have to do is restrict the domain in such a manner that the function, that the resulting restricted function is 1 to 1, and furthermore contains the range of the entire function. So the range of the cosine is minus 1 to 1, and likewise the range of this restricted cosine, and I'll kind of define that better in a moment, is also minus 1 to 1. Yeah, there's the minus 1, there's the 1, and all values in between. But the domain of the restricted cosine, unlike its brother, the domain of the cosine, which is minus infinity to infinity, the restricted domain is 0 to pi. So you lucked out in this particular problem because 4 pi over 5 happen to lie in the restricted domain of the cosine, and if that's the case, all is copacetic. I never use that word. I'm not sure I know what it means, but I think it applies here. If this value is in the restricted domain, then we can go ahead carte blanche and just take the arc cosine. Funny thing happens when this is not the case, and that's what problems 44 and 45 are about. So having now done that as a prelude, yes, there's more. Let's do problem 44. Problem 44 says, similar looking problem. Let's take the arc cosine of the cosine of minus 5 pi over, problem 44, minus 5 pi over 3. Yeah, this is right. And so if you wanted, this is 44. And so if you wanted to run ahead and say, hey, the arc cosine of the cosine just returns the argument, minus 5 pi over 3. I want to write down minus 5 pi over 3. and partial credit for trying, because you have to make sure that this value is inside the restricted domain of the cosine in order to proceed in that manner, and it's not. How do we know that it's not? I got a unit circle, I got 0, I got pi. The theta that we're talking about better fall somewhere between this angle and this angle, somewhere up here into quadrants 1 or 2. But where is minus 5 pi over 3? I can barely count these out. Here's minus 5 pi over 3. That's minus 60. Here's minus 120. Here's minus 3 pi over 3, or minus pi. Here's minus 4 pi over 3. And then right here, this crazy angle right there is minus 5 pi all over 3. It looks like it fell in the right place, but remember, the restricted domain of the cosine, restricted cosine, is the closed interval 0 to pi. Okay? Minus 5 pi over 3 is not an element of this. So, oh Lord, what do we do? Well, what we do is we find an equivalent angle that is an angle that is equivalent. Equivalent meaning it has the same cosine. In this case, here's the cosine of minus 5 pi over 3. That's 5 pi over 3. This little bar right here, yeah, I'm in a unit circle. This is 1. And so can I find an angle that has the same cosine? Yeah, it's this guy right here. It's this angle right here. I better draw it in another color. It's this guy right there, and that is pi over 3. Okay, so we're talking about the same thing. The same cosine goes here as here, same value. But now I can proceed. If I just say this is equivalent to, I'm going to say arc cosine of the cosine of minus 5 pi over 3 is equivalent to, and I'm struggling to know how to define that myself, cosine of pi over 3. It's because we're talking about the same value of cosine going into the arc cosine function. And since pi over 3 is an element of the restricted domain, all is good, and we can go ahead and take the arc cosine of the cosine and get pi over 3. And that's the answer to 44. Okay, at the risk of making the longest video on record to date, let's quickly do 45. 45 says, same thing, arc tangent of the tangent of 4 pi over 5. What is it? That's the question for 45. And, in order to do these problems, you've got to keep in mind or be able to derive, here's the tangent, right? The tangent looks like this. And so you can be pretty sure that the restricted domain, and it is, of the tangent is minus pi over 2 to pi over 2. And that way you capture the entire range. So the restricted domain of the tangent is equal to, or is the closed interval minus pi over 2 to pi over 2. And now we just have to ask or check, is 4 pi over 5 an element of this? And the answer comes back no bueno. No, it is not. 4 pi over 5 is not in between these minus pi over 2 and lies outside over here. So now I've got to go and find an equivalent angle. What the heck does that mean? It's a little bit more challenging in this case. Where is 4 pi over 5? Well, here's pi. And 80% of it is like this. And in fact, this little angle is then 180 divided by 5 is 36 degrees, I think. Pi over 5. And the tangent of this angle has a positive, what is that thing? Positive sine and a negative cosine. So the tangent is negative. So I need to find an angle over here in the restricted domain of the arctangent that returns the same value for the tangent. And that's going to be this guy right here, 36 degrees, or minus pi over 5, because he has a negative sine, a positive cosine, therefore a negative tangent, just like this guy. And so what you'd have to do is to say that the arctangent of the tangent of 4 pi over 5 is equivalent to the arctangent of the tangent of minus pi over 5. All the domains and ranges are lined up. The arctangent of the tangent of minus pi over 5 is minus pi over 5. Okay? So, just when I made everything difficult, welcome to the trigonometric functions, which make you think a little bit more when we're evaluating these composite functions.